So I'm going to be talking about a brand new product, just barely out the door, called QGen. Stands for Qualifiable Code Generator, QGen. That Q is that quality notion, and gen is the idea of automatically generating software, which sounds like a really cool idea. So what is QGen and why? That is, why would you want QGen? And I'm going to do a quick little sideline, which was last-minute slides added from another presentation I gave, which was sort of to give some of the rationale for a tool like QGen. Why does it exist, and what can it do for you? So there's been this sort of ongoing battle in various industries where you've got system engineers who come up with this wonderful design and software engineers who try to implement it. And the system engineers say, who needs programmers? Why do we have to depend on them to implement our design? We've built this beautiful thing in some modeling language, and why can't we just, push a button and get code? And then the programmer says, oh boy, they're using these circles and diagrams and squares and circles, and they think, programming with pictures, it's all so easy. Why do we need programmers? So there's a little bit of an ongoing battle here. And who's really in charge when it comes to the software? Was it the system engineer who defined the architecture, and that's really what's going on, or did the programmer really put in all the relevant details, and that's what it was all about? And I think one of the reasons why this has been a challenge is that in a traditional environment, the architects and engineers develop a design, but then they have to hand it off. There's sort of this handoff process, which the software design may not be as directly linked to the high-level design as you might hope, and the design, or the implicit design as implied by what is in the software, may evolve as the software development proceeds, because you're putting in details and you're discovering problems that weren't known. And what happens is that you can have the system engineers saying, well, this thing was supposed to do this, and you have it doing that. Why is there a difference? Well, software people say, well, it couldn't possibly work the way you had designed it, and so we had to fix it during the software design. So there's a little bit of an us versus them thing going on. The new buzzword here, model-based system engineering, model-based design, model-based development, model-based engineering. The key is the model-based idea. That is, you're going to build a model, and through a series of steps, you're going to ultimately generate some proportion of the software. And the intent is that there is a very close connection between the model and the software, and you don't then hand edit some of this generated software. You actually go and fix the model if there's a problem. So that will have a tendency to make certain that your high-level representation of the design remains consistent with the low-level representation. So how does this help reduce the us versus them? Basically because your high-level design is represented in a modeling language that allows you to generate code directly. That is, the modeling language provides enough detail that you can actually push a button and it will generate code. But often there are pieces of that code that have to be written by hand, and those are essentially, you can think of them as building blocks. So the programmers are really focused on creating the right building blocks, and some of the out-of-line code that has been very carefully designed and implemented, now allowing the system engineers to use those building blocks in their models. So the net effect is that you have parameterized, annotated, high-performance building blocks in a software development stack. And so you have the programmers who are worrying about these building blocks and also the tools that use those building blocks, and the system engineers can then use those in a very nice graphical modeling language. Okay, so what is QGen? It's a code generator. It's highly customizable in that you can actually control what sorts of code it generates. It also has built into it CodePeer, which we talked about yesterday, which can be used for doing model verification. And it's an extensible framework so that, in fact, we anticipate in the future being able to support other kinds of modeling languages. The initial release is focused on Simulink. So right now it supports a large subset of Simulink, 120 blocks. If you're familiar with how Simulink works, the blocks are your building blocks, and out of them you build a model. And some of them are very trivial. They might represent multiplication. Others might be much more sophisticated, or even that multiplication might be a matrix multiplication and so on. So it has built-in primitives for doing matrix-level operations, as well as generally higher-level control system-relevant operations. We've also now started supporting stateflow, which is essentially a state machine syntax that you can embed inside a Simulink model. So you might have one block in your Simulink model, which internally is represented by a state machine. They call that stateflow, the MathWorks stateflow, and we now can also convert that into Ada and C. So we have support for both MISRA C and the Spark subset of Ada. And we've been hearing about Spark as well. So if you want to have a formally oriented development process, you can start with Simulink, you can go through Spark, compile it, and never sort of leave a very formal representation of your program. It is integrated. We have integration at various levels between QGen and the compiler. You can do an end-to-end tool chain. So from one vendor, you can get your model code generator, you can get your compiler, you can get your debugger, your target, cross-target debugging, and so on. Integration with GNAT emulator, so that in fact, if you want to emulate a target on the host so that you can do more efficient testing and so on. You can also do coverage analysis and up to the MCDC level, so that if you have a model that you've done model coverage on, you can now execute those same model tests and do object code coverage. And as I mentioned, it includes CodePeer, which is essentially a static model verifier in this sense, and it focuses on, the point here is that a lot of these systems are safety critical, and it will find the runtime error possibilities. It will also find things like dead code and so on. And it will also, if you do put in assertion blocks in your Simulink model, that's essentially a mechanism for writing requirements at the Simulink level, lower level requirements perhaps, but they are checking the values of various signals and so on. Those are translated into Spark, for example, and then they are verified by CodePeer. And part of the features of QGen is that it automatically enforces various kinds of modeling standards. So there's a lot of different kinds of features that you could use in Simulink and Stateflow, some of which are recognized as not being safe for safety critical systems, and QGen will automatically enforce that subset for you. So MISRA has also defined various Stateflow subsets and so on. We also relax some rules which are not necessarily considered critical. Some of the MISRA rules we have been found to be overly restrictive, so we have certain relaxations in some of those rules, and we also have added certain other constraints which seem to represent cases where there were ambiguities in some of the semantics and so on. Oops, sorry. Finally, a very important aspect of what we're doing is that we are intending to build a qualified code generator, and what that means is that we will go through sufficient testing to verify that every model block that we support is turned into the appropriate C or Ada code that has a thorough test to ensure that it's exact equivalent, no added code, no less functionality than the original model block. In the DO-178C terminology, this will be TQL1, which is the highest level of qualification for a tool. There are other standards which we will also be including in our qualification activities. This is a railway standard, this is an automotive standard. Simulink is widely used in the automotive market, and in fact, I just came back from Japan where I visited a number of automotive companies who have a lot of interest in this technology. So what makes QGen interesting? It provides a safe Simulink subset. It automatically validates the subset as you use QGen. It will come with qualification evidence so that you can create a qualified environment for your development, and it has a lot of customization capability, so that if you, for example, have a special target that has, let's say, vectorization capability, and you would like to be able to use some of those vector instructions, then you have the ability to inform QGen how to use those special libraries or special instructions. As I mentioned, it's integrated with our various tools for doing compiling, debugging, verification, and so on. And one of the nice features of it is that it is a tool that you can use outside the Simulink environment. So it is integrated with Simulink so that from the Simulink environment you can start QGen to convert a model into code, or you can do it offline. You can export your models into a MDL or SLX representation, and then everything can be done from then on offline. And I'll show you some examples of that. Where did QGen come from? It was based on a project that was started about 4 or 5 years ago, funded through the European Union and France. Thank you, France. Thank you, European Union. It was called Project P originally, which always felt like a kind of a meaningless name. We never knew what the P stood for other than project. So it was sort of one of these self-referential names. Someone needed a name right away, and they didn't have quite the creativity that we usually came up with. So, one of the nice things about it is that it actually included, along with sort of the academics and so on who were interested in some of these things, it included some real users. Continental is in the automotive, Airbus, obviously, Rockwell Collins, and so on, and in the space domain. It did have various vendors, AdaCore being the one who was very involved with Project P, as was Kratos. We are actually now in a very tight partnership with this company. They are actually out of Estonia, and one of the cool things about working in the EU is you end up having with these multinational coalitions. So that's a very tight partnership there, and we also had support from academic or industrial research labs. The net effect is that all along in the development of QGen, there was a lot of testing by real users, and some of them are still actively testing the latest version of QGen, so that's allowed it to, from the very beginning, work with realistic size models. So it's not just working on small toy models, it's also actually working on big models.